Okay, good day. This is Honors Algebra 2. I'm Mr. McColley, and this is the lesson for section 2, 8.2, and we're going to break this up into two parts. So this is 8.2a, operations with rational expressions. Let's get to it. So today we are going to be determining the LCM of polynomial expressions, and we're going to add and subtract some rational expressions. So first, the definition: the least common multiple of two polynomials is the product of the distinct factors of each polynomial for each time the factor appears. Now, that's a lot of words for something that's really not too difficult. You guys have found the least common multiples of numbers like 6 and 25. And you guys usually, oh, come on now. There we go. All right, tool. Okay, and you guys usually have a fairly easy time finding this, but I want to break it down so that I can talk about the distinct factors and for each time the factor appears. All right, so the factors of 6 are 2 and 3, and the factors of 25 are 5 and 5. So the least common multiple in this particular case is going to be all of these factors multiplied together because there are no repeated factors in both of them. So there's a 2, 2 is a distinct factor, 3 is a distinct factor, and 5 is a distinct factor, and it's for each time that factor appears. So in this particular instance, the least common multiple is actually going to be the multiplication of the two values here, and it'll be 2 times 3 times 5, which ends up being 150 is the least common multiple of 25 and 6. I know that's kind of big, but that's how we find it. So we do a simple elementary example for the least common multiple of two polynomials here. X squared is a polynomial and x squared minus x is a polynomial. So in this particular instance, x squared has two factors, x, and x squared minus x has two factors. I don't need that arrow there. Has two factors, x and x minus 1 when I factor that. Those are its two factors. And so the greatest number of x's is 2. So I would need my LCM. I'm going to need the two x's here because that's the greatest number of x's. And then the greatest number of x minus 1's. And I'm going to need to multiply by that. So the LCM of this is going to be x times x, which is x squared, times x minus 1, which is going to be x to the third minus x squared. So the least common multiple of x squared and x squared minus x is going to be 3x minus x squared. Now, if we're going to add and subtract rational expressions, we're going to have to first find the least common multiple of the denominators in the addition and subtraction. And then we're going to have to multiply each fraction by the appropriate funky one so that we have common denominators. And then once we have common denominators, we're going to add or subtract the resulting rational expression. So let's look at an elementary example. So here is our elementary example. And if I talk about 6 and 15, 6 and 15, so I've got a 2 and a 3, I've got a 3 and a 5. So the LCM is going to be, well, the greatest number of 2's that occur is 1, 2. The greatest number of 3's that occur is going to be 1, 3. And the greatest number of 5's that occur is going to be 1, 5. So the least common multiple between 6 and 15 excuse me, is going to be 2 times 3, which is 6, and then 6 times 5, which is 30. So that is my LCM between 6 and 15. All right, so I need to multiply by an appropriate funky one so that I get 30 for both of these two fractions. So I'm going to multiply this first fraction. What times 6 is 30? Well, 5 times 6 is 30. So the funky one that I'm multiplying by here is 5 over 5. 5 times 6 is 30. 5 times 5 is 25. To get 15 to 30, I have to multiply by 2. So the funky one that I'm going to multiply this second fraction by will be 2 over 2. So 15 times 2 is 30. 2 times 7 is 14. 14 and 25 is 39. So 39 over 30. And I think we can take a 3 out of each term. So if I take a 3 out of each term, I'll have 13 over 10. And that is my final answer. I know that because 13 is a prime number. All right, let's do some with some polynomials. So we want to we want to add the following rational expressions. So when I look at these two things and I want to find my least common multiple, well, x has just one factor. It's x. X squared y has factors x, x, and y. So the least common multiple is going to be the greatest number of x's, which is 2, so x times x, and the greatest number of y's, which is y. And so our least common multiple between x and 2x or x squared y is actually going to be x squared y. And you have that sometimes with numbers. So just as a off to the side here, the least common multiple between 6 and 12, well, that's just 12, because 6 times 2 is 12. 12 times 1 is 12. 12 is a multiple of 12. So you can have a least common multiple that is one of these values, which makes finding the common denominator for this one actually pretty easy. All I have to do is ask myself, what times x is x squared y? Well, xy over xy is a funky one. And excuse me, when I multiply xy times x, I'll get x squared y, and that'll give me 3xy over x squared y plus 4 over x squared y. Now, the numerators are not like terms, so I can't combine those two. And so my final answer is going to be 3xy plus 4 over x squared y. All right, another one. Let's take a look at this thing. Excuse me. So I am adding two fractions and subtracting. So I'm actually doing a sum and a difference of 3 fractions. So I need to find a least common multiple for all 3 of these terms. Now, you could probably start doing some of this in your head. And just to do one more time here, 3y has 2 factors. It's going to have 3 and it's going to have y. And 9 has 2 factors, 3 times 3. And 10y squared has the factors, let's see here, 2, 5, y, and y. All right. So let's see here. The most 2's is going to be 2. The most 3's, there's 2 3's in 9, so I need both of those. And the most 5's is 1 5, so I'm going to have that. And then the most y's is 2 y's. And when I multiply that all together, 2 times 3 is 6. 6 times 3 is 18. 18 times 5 is 50 and 40, so 90 y squared. And that looks like that is going to be the least common multiple. All right. Well, I'm going to rewrite this, and I'm going to separate it so I can do all my funky ones. So I have my 8 over 3y, and to get 90y squared, I'm going to have to multiply by 30y over 30y, and so plus. Now, to get 9 to 90y squared, I have to multiply it by 10y squared. Oops, let's see what happened there. 10y squared over 10y squared, and I don't know why I'm getting that. Let's go back to this and see if we can. All right, so let's go 10y squared over 10y squared, and that'll be times 2 over 9. And then we're going to subtract here. And so to get 90y squared, I have to multiply 10y squared by 9 over 9. And it'll be 3 over 10y squared. And let's multiply that out. So 30 times 8 is going to be 240 over 90y squared, plus 10y squared times 2 is going to be 20y squared over 90y squared. Oops, and let's just redo that, 90y squared. And then when I multiply that, 9 times 3 is 27 over 90y squared. Now here's the good news. None of these terms are like terms. So I'm just going to rewrite them. And I made a slight, I see I made a slight mistake here. So when I go 30y times 3y, I'll have 90y squared. And so 30y times 8 should have been 30y. I'm sure some of you caught that. And let's see here. So 20y squared plus 240y minus 240y minus 27 all over 90y squared. Okay. Moving on. If you get some polynomials that look like this. Okay. Well, we're going to need to factor both of these two quadratics. And so these two quadratics are a little bit more difficult to factor because I've got my a leading coefficient of 4 and a constant term of 2. So we got to kind of review how to factor quadratics. And so if I go 4x squared plus 9x plus 2, I'm going to multiply the a and the c value. So a times c is going to be 4 times 2, which ends up to be 8. So I need two factors of 8 that add up to 9. Well, 1 times 8 is 8, and 1 plus 8 is 9. So I can factor this thing, and I'm going to go, let's go, I think I'm going to flip these, and I think I'm going to go 4x squared plus 8x plus 1x plus 2. Now, again, you would never write as a final answer 1x, but just for right now, we're not actually finishing this problem. So I'm going to leave it there for now. And let's see here. I'm going to group these first two. So I'm going to have 4x squared plus 8x, and then it's going to be plus x plus 2. All right, so if I factor out, if I find a least common multiple of, or greatest common factor of 4x squared and 8x, well, 4x factors both of those. And if I factor out, I'll get x plus 2, which is good because it's the same as this x plus 2. So I'm going to factor out an x plus 2 from both this term and the second term. And when I divide 4x times x plus 2 by x plus 2, I'm going to be left with 4x. And when I divide x plus 2 by x plus 2, I'm going to get 1. So the factorization of this first polynomial is going to be x plus 2 times 4x plus 1. So if I want to factor this second one, I have 2x squared minus 8x minus 24. This one's a little bit more challenging because I got to go 2 times 24, and 2 times 24 is going to be 48, and it's negative 48. So I need two factors of 48 that is going to add up to negative 8. Let's see here. Oh, I see it. It'll be excuse me, it'll be 4 and negative 12. So 4 minus 12 gives me negative 8. 4 times negative 12 gives me negative 48. So that's going to work. And so I'm going to write it like that. So I'm going to go 2x squared plus 4x minus 12x minus 24. And then I'm going to group both of those, the first two and the second two. So when I group these first two, I'll have 2x squared plus 4x. And then when I group the second two, I'm going to remove the negative. And so I have to, since I'm grouping it, I would have to distribute the negative to both terms. So I'll have a positive 12x and a positive 24. All right. So the greatest common the greatest common factor of x squared and 4x is going to be 2x. That'll leave me with, let's see, it'll leave me with x plus 2, that's good. And then when I factor out a 12, I'll have x plus 2, and that's good. So I will have 2x minus 12, and then I'll have times x plus 2. All right, so you'll notice that there is an x plus 2 in both of these two sets of factors. So my least common multiple here, LCM, is going to be x plus 2 times 4x plus 1 times 2x minus 12. Okay, so I'm not going to multiply all these out. That's going to make things difficult. So I'm just going to leave my least common multiple as the product of these three factors. But I come back up here and I remember that in this particular instance, I have 2x and then it's over this factorization. So x plus 2 times 4x plus 1, and I need to multiply that by the 2x minus 12 over 2x minus 12, and then to that we're going to add 3 times its factorization, and remember that was 2x minus 12, let's get that correct, 12 times, let's see here, it was x plus 2, and so I have to multiply this fraction by, let's see here, it is 4x plus 1 over 4x plus 1. All right, so when I do that, my denominator for the whole thing is just going to be 2x minus 12 times x plus 2 times 4x plus 1. Now my hope is I'm going to be able to do something with the numerator that'll cancel one of these factors. I don't think it's going to happen, but let's hope. So when I distribute here, 2x times 2x is going to be 4x squared, and then negative 12 times 2x is negative 24x. And then 3 times 4x is going to be positive 12x, and then 3 times 1 is going to be 3. So I'm going to simplify this, and I'll have 4x squared, and then negative 24 and positive 12 is negative 12x, and then I'll have plus 3 there. And let's see here, does this factor, 4 times 3 is 12, two factors of 12 that add up to 12? I don't see any, because I need two negatives. No, I don't see any that is going to. So this isn't going to factor into rational values. So I'm just going to leave it as 2x minus 12 on the bottom times x plus 2 times 4x plus 1. And that's going to be the end of that. Now I know that one's pretty tough, but I don't have too many like that. So Mr. McColley's fun fact of the day. This is my command center for the foreseeable future, since we got a couple weeks of online learning. This is what I've got. I've got my main computer and then my school computer there over on the right-hand side so that you can see me through the webcam. That's all I got for today, folks. Have a good day. Bye.